All right, in this lesson we're going to finally get down to that fourth transformation, dilation, that is growing or shrinking an object, causing it to get larger or get smaller. We're looking at Unit 8, Lesson 2 in Geometry A right now. We're going to start with a line segment. And what I'm going to do is I'm going to double the line segment. So AB, A is 1, 2, B is 4, 1. And I'm going to double that segment. So in transformation notation, that's going to look like this. XY becomes 2x, 2y. Okay? And watch what happens when we do that. So A is 1, 2. So A prime is going to be 2 times 1 and 2 times 2. 2, 4. B is 4, 1. So B prime is going to be 2 times 4, 8, and 2 times 1, 2. And let's go ahead and plot those. And let's see what properties we notice here. So we're going to go 4, 1, or 4, 2, 2, 4, 2, 2, 4, A prime. And B, 8, 2. 2, 4, 6, 8, 1, 2. B prime. So B prime, 8, 2. A prime is 2, 4. Okay. And take a look at these 2 points and see if you notice anything. One of the things I notice is the lines seem to be parallel. They're parallel. They have the same slope. Let's check that out. Let's check the slope of A prime, B prime. Change in Y. So Y goes from 4 to 2. 4 minus 2. Change in X. X goes from 2 to 8. 2 minus 8 is 2 over negative 4, or negative 1/2 if we reduce it. And the slope of AB is, change in Y, 2 minus 1. Change in X, 1 minus 4. 2 minus 1 is 1. 1 minus 4. 2 minus 1. 1 minus 4. Oh, good. I see the mistake. Is negative 3. Negative 1/3. It's not 1/2. 2 minus 8 is 6. And so 2 6 is 1/3. Negative 1/3. So the slopes are the same. Okay? The slopes are the same, and these two lines are parallel. Parallel. What's more is their lengths are related to each other. Let's use the distance formula here. The distance formula for AB. AB is, change in X, 1 to 4 is 3 squared. Change in Y, 2 to 1 is 1 squared, square root. 9 plus 1, square root 10. And A prime, B prime, A prime, B prime is, change in X, 2 to 8 is 6. 4 to 2 is 2. 6 squared is 36. 2 squared is 4. Root 40, but check this out. That's root 4 times root 10. 4 times 10 is 40. And the square root of 4 is 2. This is 2 root 10. This is twice as long as AB. So AB, A prime, B prime, is twice AB. So it's twice as long. So we've doubled the length, and we've created a new line segment that's parallel. This can be used to dilate polygons and dilate shapes. So let's do another example here. Let's use a scale factor that's smaller than 1. Let's draw a triangle. I'm going to draw a triangle here. Right here, 1 point right there, 1 point right there, and 1 point right there. Okay? A, B, and C. And note that I've drawn them so that they're all in separate quadrants. So that's the center, the origin, is included inside the triangle. I think in the lesson they always put one of the vertices on the origin, and that's fine. Just remembering that when you multiply by 0, you get an answer of 0. Okay, so A here I have -3, 2. B here I have 3, 3. And C here I have 1, -4. Okay, and I'm going to dilate by this rule. I'm going to say xy becomes 1/3 x, 1/3 y. Okay, so A is -3, 2. A prime is 1/3 of -3, which is -1. 1/3 of 2, which is 2/3. V is 3, 3. So V prime, 1/3 of V is 1. 1/3 of V is 1. And C is 1, -4. C prime, 1/3 of 1 is 1/3. 1/3 of -4 is -1 1/3, or -4/3. But -1 1/3 is easier to follow and understand. Okay, so let's go ahead and plot these points. A prime, -1 2/3. -1 2/3 right about here. I'll leave off the coordinates because it's going to get a little crowded. B prime is 1, 1. C prime is 1/3, -1 1/3. C prime. Okay, and if I'm careful about this, you may notice that the lines are parallel. The lines are parallel to the original sides of the triangle, but also that this triangle is 1/3 as big. It has been reduced to 1/3 its original size. It has been dilated, or more specifically reduced, by a scale factor of 1/3. Okay, I want to show you, and I know that's going to make the video a little bit longer, but I want to show you how to play around with this in Desmos as well. And so just to recap this example, we have A prime B prime, which is 1/3 the length of AB. It takes 3 of them to make the length of AB. You can verify that yourself. Then A prime B prime is parallel to AB. And BC is parallel to B prime C prime, and AC is parallel to A prime C prime. And all the sides are 1/3 the length of the original. All right, so let's go to Desmos, and I want to show you something in Desmos here. Desmos. I had Desmos open. There it is. Okay. And let's go ahead and maximize the screen. And let's plot a polygon here. So insert a table. And let's say 3, 5, and 2, -4, -2, yeah. And -6, -1. Okay, And let's draw a triangle here. Oh, to draw a triangle, we've got to close the loop, 3, 5. Otherwise, it won't close the loop. And click and hold and turn on lines. There's our triangle. All right. And so what I want to do is I want to multiply by some scale factor. I'm going to do this. I'm going to add a new table. I'm going to add a new table. And we're going to get plus table. I'm going to use the same coordinates, but I'm going to multiply all of them by k. 3k, 5k, 2k, negative 2k, negative 6k, negative 1k, 3k, 5k. And now I'm going to define k. K equals 1. Okay, and now the hourglasses or the exclamation marks are gone. Okay, but what I want to do here is I want to add a slider here. K between 0 and 3. And step size I'm going to leave blank here. So right now k is 1, and you'll notice that there's just one triangle. But as soon as it would help if I turn on line drawing. Line drawing. There we go. And so for a scale factor, this k is called the scale factor, or the multiplier is called the scale factor. For k equals 1, the triangles are exactly the same. When k gets bigger than 1, the triangle enlarges. It gets bigger and bigger and bigger and bigger, right? When k gets smaller than 1, the scale factor gets smaller than 1, it gets smaller, it reduces. So a scale factor between 0 and 1 will result in a smaller shape, and a scale factor greater than 1 will result in a larger shape. But notice again the principles we've got. The black lines are all parallel to the red lines, right? And the lengths are proportionate to the scale factor. In this case, 1.28. So the black lines are all 1.28 times longer than the red lines. Okay, hopefully that helps.